Hi, my name is Kiandra Rajala, and I'm a research associate at Virginia Tech. I'm happy to be presenting losses loom larger than gains when private landowners evaluate overall impacts of invasive species. This is from a paper we currently have in press in the journal Ecosphere. And before I begin, I'd like to thank my collaborators, Mike Cerise and David Toledo, and of course, all of the landowners who participated in this study. People can steer ecological transformations based on their perceptions of invasive species. As scientists and practitioners, we typically view introduced and invasive species negatively. However, resource users may hold a greater range of perceptions and experience varied outcomes as ecosystems and ecosystem services change. Take something like Kentucky bluegrass, expanding throughout the northern Great Plains of the United States. We know it outcompetes native grasses and may negatively impact a number of ecosystem services. However, some people may see benefits, like early season forage available for livestock. Considering the perceptions and preferences of different stakeholders is important for the legitimacy, acceptability, and overall effectiveness of invasive species management and conservation at large. This is emphasized on private lands, where landowners often have considerable autonomy and may also face many constraints in how they manage their land. Kentucky bluegrass is our species of concern, but it's one of many grasses that have or may become invasive in the northern Great Plains. With this in mind, we designed a study to gain broad insights about how changes in ecosystem services relate to landowners' acceptance and management intentions for invasive grasses. As a case study, we used 9 counties of North Dakota that create an east-west transect across the state. This captures major variations in regional geography and land use, which transitions from primarily crop production in the east to primarily livestock production on rangelands and pasture in the west. We sent a mail survey to 1,219 landowners who owned at least 1,000 acres. Within our survey, we employed a factorial survey experiment using vignettes describing how a new unnamed grass expanding on rangelands would affect 7 ecosystem services. Vignettes provide respondents with context to make decisions by having them evaluate a series of scenarios with different outcomes. This is really useful for something like an invasive species, which may have a high degree of uncertainty. Because the vignettes are based on an experimental design, they enable the researcher to identify determinants of decision drivers that respondents themselves may not be fully aware of. We can then quantify the influence of these different factors and explore their trade-offs. So what does this look like? All of our vignettes started with a static introductory statement introducing a new grass expanding on native rangelands. In this example, the grass does not affect the variety of grassland birds, decreases floral resources for pollinators and water availability, provides average forage quality, is available only early in the grazing season, moderately decreases other grasses, and provides increased forage quantity. For each vignette, landowners rated the grass's acceptability and indicated how they would manage it on their rangelands. Each landowner responded to 4 different vignettes. Because of repeated measures, we analyzed this data with mixed effects models. The vignettes were based on an experimental design where 7 ecosystem services were measured at 3 levels. These included provisioning services related to season of forage availability, forage quality, and forage quantity, regulating services of floral resources for pollinators and water infiltration and availability, and supporting services of grassland bird diversity and grass diversity. The variables and levels were selected based on the literature, expert opinion, and landowner interviews. For most services, levels reflected a decrease, no change, or increase in the service, except for forage availability and grass diversity. All services included a status quo level, which is shown in gray and was typically the no change condition. I want to note that we do not have any cultural ecosystem services, although cultural services are certainly important to landowners and people in general. We don't have them because in our developmental phase, landowners indicated they considered cultural services, like sense of place, more as an outcome of other ecosystem services. This conceptual difference wouldn't work with the way we were measuring ecosystem service changes in our vignettes. 206 landowners provided usable responses to the vignettes and were included in this analysis. These respondents look like full-time agricultural producers with primary land uses split between livestock, crops, and mixed production. Thinking about what influences management of an invasive species, we'd expect ecosystem services to influence how acceptable the species is. This evaluation of acceptability should then relate to management intentions. Working backwards, we found that acceptability does indeed explain a large amount of variance in intentions. The more unacceptable landowners viewed a new grass species, the more likely they were to intend to reduce or control it. For the rest of the talk, I'll focus on explaining acceptability. All ecosystem services were significant in understanding the acceptability of a new invasive grass. If a grass doesn't change the status quo, which was summer availability and no change to other services, it was almost slightly acceptable, this gray line. It's useful to think of this line as a baseline, and you'll see it repeated in the following figures. First, we can look at how expected acceptability changes when a single ecosystem service changes, holding all others constant. Starting with provisioning services, spring forage availability is less acceptable than the status quo of summer, but fall availability made little difference. For both forage quality and quantity, increases and decreases in the service relate to symmetrical increases and decreases in acceptability. In regulating services, decreases in floral resources reduce acceptability to below that neutral point, but increases made little difference. For water infiltration and availability, increases and decreases in the service yield proportional increases and decreases in acceptability. And in the two supporting services, we see that for grassland birds, only a reduction in diversity has a noticeable impact on acceptability, which is reduced. Decreases in grass diversity are increasingly unacceptable. Next, we can look at combined changes, turning the ecosystem service dials, so to speak, to explore trade-offs. In the maximum gain scenario, if all services increase or are at their preferred levels, we'd expect landowners to rate the new grass as moderately acceptable. Enhanced provisioning services relate to an increase in acceptability, but if these forage benefits are accompanied with decreases to regulating services, gains in acceptability are outweighed and acceptability drops below the baseline. If provisioning services are decreased, but both regulating and supporting services are increased, acceptability remains below the baseline, near neutral. If both regulating and supporting services are reduced, but provisioning services are unchanged, we'd expect a drop to moderately unacceptable. And finally, if all services are reduced, we see an 84% decrease in acceptability and would expect the new grass to be extremely unacceptable. We can also model profiles of known invasive species like Kentucky bluegrass at different levels of invasion. Based on our model, we'd expect landowners to find bluegrass outcomes slightly acceptable at early stages if it provides forage benefits in the spring. When we incorporate negative impacts that are expected as bluegrass becomes more dominant, we see that acceptability decreases. At advanced stages of bluegrass invasion, which includes spring forage enhancements, along with losses to floral resources, bird diversity, and grass diversity, we'd only expect landowners to consider the species as slightly unacceptable. And finally, we can map these scenarios back onto the management intention model you saw earlier. Starting with the baseline, we see that landowners aren't likely to change their current management if a new invasive grass doesn't change the status quo of ecosystem services currently provided. A number of scenarios are associated with maintaining current management, and these all included combinations of losses and gains. The scenarios in which landowners may promote or maintain the new species are those in which forage quality and quantity are enhanced, with minimal to no losses in other services. And as ecological losses become more severe, we expect stronger management intentions towards reducing or controlling the species. The only scenario in which management intentions were definitive towards control is that max loss scenario, where all ecosystem services were reduced or at their least preferred levels. In conclusion, landowners demonstrated loss aversion when evaluating ecosystem service trade-offs. They were more sensitive to losing services than to achieving equivalent gains. We saw this in specific services such as floral resources and grassland bird diversity, and it's really highlighted by that contrast between the max gain scenario and the max loss scenario. This can be understood through prospect theory, which posits that losses are psychologically more impactful than equivalent gains, especially under conditions of risk and uncertainty. The scenario modeling of ecosystem service trade-offs paints a nuanced picture of agricultural stewardship. While provisioning services were important to landowners in our study, they were not the only thing that mattered, and they did not dominate evaluations of trade-offs. Forage quality and quantity may be more focal when landowners make decisions related to enhancing outputs. However, a wider range of supporting and regulating services may become important when landowners make decisions related to preventing losses. Although there is a strong relationship between acceptability and management intention, ecological losses may need to be quite severe before individual decision makers change their current management to control an invasive species. Landowners are more likely to be reactive than proactive. These high individual thresholds underscore the need for collaborative engagement and conservation efforts. Along with other benefits, collaborative processes can encourage landowners to redefine their system of interest from the individual farm or ranch unit to the landscape scale. In regards to invasive grasses in North Dakota and the northern Great Plains of the United States, collaborative efforts, whether to control and eradicate a species or guide management towards coexistence, are likely necessary to maintain desired biodiversity and the flow of ecosystem services. That concludes my talk, and I'm happy to answer any questions in the live Q&A or over the conference app. Keep an eye out for our paper, and please feel free to get in touch. Thank you.